Thank you all for being here. Good afternoon. Welcome to this session on best practices for secure big data lake on AWS. My name is Varun Rao Bhamidi Murray. I'm a solutions architect with AWS. With me on stage is Tony Ingen, who's a senior big data consultant with AWS. So before we get started and get into the details of securing data lake, we wanted to set a few high-level expectations, what we want you to leave this session with. Three main things we want you to leave the session with. First, understanding the value proposition of why a data lake on AWS makes sense and how to build it. The second is to get a sense of the best practices that are involved to secure it. And finally, the roles and responsibilities that are required in order to make that happen. The way we would approach this is through a scenario-based approach. We would actually have a sample data set. We'll look at how the different access patterns will be used, and then based on that, we'll provide best practices to secure it. A few assumptions and housekeeping before we move on. This is a 300-level session, so we do expect some foundational AWS knowledge. We do assume some of the high-level understanding of the AWS analytics services, as well as some high-level concepts around security. So this is things like SSL and TLS, encryption, authorization, authentication. So these sessions are recorded and will be shared online, so you don't have to take pictures if you don't want to. The other one is this is targeted to anyone who's looking to build a secure data lake on AWS. So any conversations that you've been recently having within your organization about data lake and securing it, this should give you a good start. Finally, I want to really emphasize on this fact, please submit your feedback. This is a new session. We haven't had this before. We would really appreciate some feedback in order for us to improve this going forward. So with that, I'm going to hand it over to Tony, who's going to walk us through some foundations around data lake.
Thanks, Varun. So show of hands, who here has used S3 as their data lake? Cool. Who here has a data catalog as part of that solution? And who here thinks that they have a secure data lake today? Well, that's what we're here to help with, right? So let's go ahead and get started. So level setting. What is a data lake? So it seems that most of us here know at a high level what a data lake is to some extent. But the four key premises I would like to just make sure that everyone's aware of is that you want to be able to collect and store all your data at any scale at low cost, right? You want to be able to help locate, curate, and secure your data for your users. You want to be able to provide that sort of democratized access to that data. And you want to be able to enable your users to perform new kinds of analyses and faster kinds of analyses on that data. And really, that's what customers need, right, when they're looking at a data lake. They want something scalable, secure, and really something comprehensive. And there are a couple of 10 key attributes of a modern data architecture that you may have seen in past reInvents or summits or what have you. And they kind of serve as a guide for what's needed for a mature data strategy in any organization. It's not to say that you need all 10 of these, but it's a good place to start, if you have a good amount of them. I want to have these pillars be the fundamental guide through which we look at how we secure a data lake. And for the rest of the session, I do kind of want to actually boil this down to even 3 lower level components, that being compute, catalog, and storage. And you'll notice down there that I'm saying architectural layers of a data lake without security. And that's kind of strange, right? We're in a security session right now, but I'm saying no security. But I have a good reason for that. And I'll dive into that later in the session. So let's go ahead and quickly go through what each layer is comprised of. So let's talk about storage first. So storage, right, is not just your storage on EC2 instance. You need to consider object-level storage. That's storage on S3 or Glacier. You need to consider block-level storage, stuff in EBS, stuff on, say, EFS, stuff on your attached instance store on EC2, stuff in your Redshift clusters, and some things that might not necessarily be intuitive, right? Your storage when you're using Kinesis, that's storage. Your storage when you're using DynamoDB, you need that to be secured as well. And so when you're going through a sort of security assessment of your services and how you're using them in AWS today, you need to be able to clearly and cleanly articulate how you are securing each one of these different kinds of storage. Second, metadata and catalog. It's not necessarily mandatory to have a catalog in this day and age when people are talking about data lake, right? You have plenty of people that are just using S3, doing some sort of batch workloads, and then calling it a day. That's my data lake. And really, you need to be working towards having a strategy around cataloging your data, storing the metadata of your objects, because that enables you to do a bunch of things, right? You have indexed your data. You're able to search on it. You curate it. You're able to really target data for your users and enable them to search that data for themselves. Last but not least, compute. And compute by itself is more than just EC2, right? You have EMR, you have Redshift, you have Redshift Spectrum. You have serverless compute, such as Athena, Lambda, API Gateway. And you notice down at the bottom, I mentioned a sort of hybrid approach. Spectrum shows up again, right? And these kinds of different models of how you can run compute on your data really have changed in the past couple of years, right? And you need to be able to define how you're running compute on your data as well. So that's nice that we really identify those individual components, right? But how do we actually do it in AWS? So this is a general overview diagram of what a data lake looks like in AWS. You've probably seen it to some extent. And we're going to go through each one of the components just as a level set quickly. So ingest, you ingest through maybe a VPN connection, maybe through a direct connect, maybe a Snowball appliance or a Kinesis Firehose. If anyone's been catching up with the updates and news recently, we just recently released a new service called DataSync, making it a lot easier for you to sync your data from on-prem to S3. So give that a look. Another feature that we have is also secure FTP for S3. That's also relatively new, so give that a look as well. Varun will go deeper into those. Processing, you can use EMR, you can use EC2, you can use all sorts of things to process your data, right? And you want to massage it into a format that you later analyze. And you want to be able to choose the right tool for the job to process and analyze your data. And while this diagram kind of shows that flexibility, right? You can bring your own tool. You can kind of do all kinds of cool things with the data lake, the flexibility that it provides. It's really challenging to secure all these tools because it lets you choose the right tool for the job, but it makes it really challenging to have a single unified solution to secure all of it. For example, EMR is comprised of more than 20 actually, open source applications from the big data ecosystem. And each one of those has its own special Snowflake way of securing itself, right? They try to standardize sometimes, maybe Kurberize your cluster, but for the most part, you have to consider each one of those tools in isolation. And remember the layers from before? Separating your data lake into those discrete layers makes it easier to tackle this challenge, right? It's still hard, don't get me wrong. But if you're able to kind of think of them in those kinds of separate layers, security is actually part of each layer. And so from storage to metadata to compute, you should be looking at each of those layers with security in mind. So let's go ahead and dive deep into what's required to actually secure those layers. So it really helps to first start off with the common challenges that many customers have. Raise your hands if you have any of these problems. I expect to see all hands up because these are very common problems across all enterprises. And you can kind of separate these challenges into data challenges and management challenges. And sort of splitting it this way can help frame the discussion. So shared responsibility model. Again, show of hands, who's aware of it? And it's typically something that's very glossed upon, right? You look at a deck and it's like, oh, shared responsibility model, AWS is responsible for this chunk, customer is responsible for this chunk. Yay. Well, we need to go even deeper than that. The shared responsibility model with respect to AWS services is actually further broken down into 3 separate classes, in my mind anyway. Infrastructure services, managed services, and serverless services, where we consider the control plane and data plane as part of our evaluation. And from end to end, these kind of represent a spectrum of how each service can have a different balance of customer responsibility and AWS responsibility. So for example, EC2 and EBS, right? You, as the customer, are fully responsible for what happens within your EC2 instance and on your EBS volumes. The control plane is really fully separated from the data plane. In contrast, serverless services such as Athena, or S3, the control plane and the data plane are unified. There's a single endpoint that you talk to, and you really only have, say, IAM policies that you have to worry about when you're securing it. Managed services such as EMR and Redshift kind of sit in the middle, right? We help you provision those instances, but they actually still exist as EC2 instances, right? In the EMR cluster, the EMR console, you have EC2 instances that show up. Redshift, you can choose EC2 instances. But the level at which you can control and secure these EC2 instances are different between the two, right? EMR, you have root level access to your instances. So you need to be able to secure the local file system, for example. Whereas for Redshift, even though it's still an EC2 instance, you don't have that root level access, but you still need to consider auth-in and auth-z when you're looking at securing a Redshift cluster. Let's dig a little bit even more deeper into the differences. So as you can see with serverless kinds of services, right, you have less to worry about. AWS takes care of a lot of the securing of it, and you have an IAM policy really at the end of the day to care and feed. And it's super important to understand where IAM is protecting you and where it's not, because that's what you are responsible for as a customer. And because IAM controls permissions at the API level, there are two very important implications. The first one is that IAM extends into these services like S3, and can be used to control access to actions in S3 and even individual S3 objects. And that's because S3 is a fully managed service that's only exposed via API. And that's in contrast to EMR and Redshift, where IAM only controls the outside of the cluster, right? You can control what the cluster talks to some extent. You can control the creation, the modification, the termination. But within the EMR cluster itself, a user could do whatever they want, right? If they logged in as root, they have full control over that system. If, for example, you have a user that logs into an EMR cluster that has very permissive IAM policies attached to it, you've really just had a bad day. And it's actually happened. and it's something to consider. It really is. So keep that in mind. Whenever you're evaluating services, think about the shared responsibility model, because that really does help frame security evaluations. So we've really mapped out how challenging it can be, right? So let's go ahead and start with some best practices and go over how you can secure the cloud. So we provide a bunch of services and a bunch of features to help you secure the cloud, right? I'm sure most of you are aware, at least to some extent, the breadth at which we help the customer do so. Let's go ahead and focus on S3, right? And this is just one example. We really want to help remove that undifferentiated heavy lifting of securing your resources so that you can focus on your core competencies, right? So S3. S3 gives control at the object level, right, rather than the bucket level. It allows you to apply access controls. It allows you to do logging. It allows you to audit your policies at account and object levels. It supports 3 different kinds of encryption. You can do KMS, server-side, client-side. You get data encrypted in transit. You can use separate accounts for, say, cross-feature replication so that you limit your blast radius if there's insider threat, things like that. There's also cross-compatibility between services. So for example, Amazon Macy, it's an AI-powered security service. Who's used it here? I really encourage that people actually take a look at Macy if you can, because it really helps your security teams monitor, detect, and alert on anomalies within S3. And one example of how the cloud model has really kind of changed how people look at securing their resources, especially big data and data-like resources, is how you look at ownership, right? Historically, on-prem systems, you have the notion of being multi-tenant is basically a given, right? You are sharing with somebody. It's very rare that you get a cluster all to yourself. And you have multiple users, you have multiple groups that all have their own groups within AD, and they all need to kind of play happily together. In contrast, if your business can allow for it, you want to be able to actually look at taking advantage of the unique proposition that the cloud gives, letting you spin up an 100-node EMR cluster with a click of a button, and giving that cluster to a single user or a single team. By having access control be at this sort of coarse-grained level, you can control things with IAM. And you can also reduce the attack surface or the surface area at which you're at risk of a credential being lost because it's only allocated to one user or group. If you have your resources dedicated to teams or groups or users, you can govern access much easier. Remember, you should also encrypt everything. The intersection of your key management strategy and your encryption point is your S3 encryption mode. And depending on your workload, the choice of S3 encryption mode is very important, right? If you're doing client-side encryption and your application depends heavily on leveraging SSE on S3, the security team's concept and the application team's concept are eventually going to collide 2 weeks before production, and you're in trouble. You also need to fully understand how you're fully auditing and logging access and activity within your environment. And S3 lets you see all API calls, right? Athena lets you see all API calls. You really want to leverage tools such as CloudTrail with these services because they basically list all the activity for you. Makes it really easy to audit. It simplifies security analysis, postmortems, all that kind of fun stuff. And just to level set again before we go on, here are some key fundamental things I think that everyone should be doing, right? Everyone should be doing in the cloud. So you want to be able to federate your accounts with AD or your IDP, right? You don't want to have to manage multiple accounts. Let's say a user or an employee leaves your organization. You have to track down every single place that person has been and deactivate their account. Whereas if you have it federated, that's just one less place to look. MFA, root account credentials, encryption, that's the basic list. So as Vinod was talking about before, let's go through a scenario-based approach to talking about security in a data lake. And we'll be covering a bunch of scenarios, all centered around this notion of users or roles that interact with the data lake. And so for example, let's say you have a developer with programmatic access to the data lake and they want to run a Spark SQL job against data in S3 and convert it to something. That's one potential workflow. Another workflow might be you have an analyst who wants to view data with masked column values. That's another workflow. Another one might be you have a business user, right, who really only wants to use the data lake as a really easy to search repository for their documents, like say Excel documents, right? That's another use case. And all these roles have actions and responsibilities. And it's really useful to think of them in terms of producers and consumers. There's a clear source of data, and there's a clear consumer of data. And you can separate rights and responsibilities based on whether or not they are producing or consuming a particular data set. So a brief aside here, and I do want to make this a very big point that I want you to walk out of here with. The data catalog is extremely important. Through 2018, 80% of data lakes will not include effective metadata management capabilities, make them inefficient. I saw probably about less than 20% of hands go up when I asked about the catalog. So pretty accurate. And with the purpose and importance of catalog kind of established, let's go through the first scenario where a data lake owner, or that is a data owner, wants to onboard a new data set, right? They have a new data set, and they have to talk to a developer or data engineer to create that data set definition, right? To give it a schema or something to that effect. And then you need to talk to some data engineer to actually have it be loaded or staged as raw data inside of your environment. And then you have a data curator or some other person operating in a similar role, registering that raw data, let's say in S3, against that data set definition that was established, right? I mean, this kind of is intuitive, but at the same time, you'd be surprised how often a security assessment will go through and they forget that the developer actually has rights to see every single S3 object. Whoops, they weren't supposed to. But because they're an ETL developer, they like that freedom, they like being able to touch everything, but that actually exposes a huge risk for that data. Let's say that workflow has successfully completed. Another workflow is to be able to take place where you want to be able to search for that data in the catalog and access it. And there are discrete actions for each of these, right, per role. It's not to say that this needs to be a really slow manual process, right? All this can be automated to some effect. But the important thing that I want to take away from this is that you want to be able to understand the multiple roles that are involved for a particular workflow, right? Because it helps you kind of identify what you need to secure. So let me go ahead and pass it over to Varun to go through some security workflows.
Am I gone? All right. Thank you, Tony. So as Tony just mentioned, the different roles that the organization might need to have in order to have a secure data foundation, we'll look at the first role that comes into mind, which is called the security administrator, and look at some of the tasks that he or she has to go through in order to actually secure the data lake implementation. So the first thing as a security admin is to understand the different access patterns, the different analytic tools that are involved. Again, this is going back to some of the slides that Tony kind of mentioned, but if you kind of go from left to right, you start from the centralized storage, right, which is usually the S3. We have a catalog, which service that sits on top of it that helps catalog the information. And then in the middle is the different processing engines. So this includes things like Athena, EMR, Amazon Redshift, and Amazon Redshift Spectrum. And from the access perspective, there are tools like Amazon SageMaker, which helps you build machine learning models, deploy, train, and build machine learning models, and also web-based notebooks like Zeppelin and Jupyter. And also things like JDBC endpoints to access and connect to services like Presto that's running on EMR or Redshift Spectrum. So really at a broad level, if you look on the right, the three types of access patterns can be categorized as programmatic access, a SQL-based access, or an API-based. So when I say programmatic access, it could include things like PySpark or a Scala-based access. Others, SQL-based access can be things like Hive, Presto, and Spark SQL. This is usually the most standard way of accessing the data. And finally, the API-based. An example of that is Amazon Athena. It helps you make an API call, submit your query, and actually get streaming results back. So really, as a security admin, it's very important to understand those security patterns across the organization. Moving on, just high-level tasks that might be involved. So starting with guardrails. So as a security administrator, you are responsible to set up the security guardrails, which includes things like preemptive and detective controls. We'll talk a little bit about that. Also to actually understand how the access across environments go through. So think about dev environment and staging environment and production environment. So when data access goes beyond a specific environment, that's when an security administrator should be involved to make sure the right set of data classification rules are applied, making sure the data consumer or the data producer are in sync. There's the right set of rules that are followed to make sure if the producer says this is the column that the consumer has access to, that's being followed. And finally, just running regular audits. So going into some preemptive and detective controls, Amazon S3, we call it the centerpiece of our data lake architecture. It's important to understand how to use things like bucket policies. So you can use things like bucket policies to restrict access based on a VPC that the data is being accessed from, or a specific IP address. A couple of other useful things that you could use as a part of the IAM policy is things like tags and conditions, extremely important. So if you look at a couple of examples that I'm showing, the first one shows how you can use a tag-based control or condition, where you can say this S3 bucket or this S3 object can only be accessed by this user, and only if that has a specific tag which is HIPAA equals true. The second one is actually using what's called user agent. So think about an example where you want to only enable Redshift Spectrum access to this S3 bucket and not any outside access. So you don't want users to directly access the S3 bucket or through other ways. Only way to access is through Spectrum. So you could do that through this conditional statement. A few other things are pretty standard, things like enabling encryption and enabling versioning and MFA delete, backups across regions. A couple of new things that were launched recently. Back in July, we launched this feature called IAM Permission Boundaries, which lets you control what the user has access to. So think about this as an S3 star that is given to a user, but the boundary actually locks it down so that it cannot do things like deleting a bucket or maybe updating a bucket policy. So it kind of overrides whatever the explicit IAM policy that's been applying to the user. Finally, the last one, recent announcement came out back on 15th of November. This idea of using access setting, a public access setting. So think about this as a way to restrict public access at a bucket level or an account level without having, and that can override any other bucket policy. So it's something that's available now. If you go to the S3 console, you'll be able to actually see this and apply this public access setting. Okay, moving on to detective controls, which touched upon a little bit. So starting from AWS config, it is a way to track resources and inventory changes. It helps you look at things like, I'm kind of showing a few of these examples, a few of the config rules, things like public read, public write, or SSL only requests. So you can enable these config rules that will automatically check and notify you when there is a variation. If somebody changes the SSL request only parameter in the bucket policy, or if it's somebody makes it a public read or public write, you'll get notified on that, and you can take corrective action. CloudTrail, again, very important. CloudTrail also has this idea of data events and management events. So data events are events, things like S3 access, or somebody's making a get call or a put call. All those requests get get logged through data events. A couple of services that are currently supported is S3 and Lambda. And what's nice about this is if you Kerberize your EMR cluster to enable a cluster level authentication, the information, the AD level information of the user is actually passed down directly to the CloudTrail data events. A couple of the services we just touched upon, Amazon Guard Duty helps you, it's a managed threat detection as a service. It can look at things like CloudTrail and VPC flow logs, the DNS logs, and do things like anomaly detection. Very important, very useful service, something that as a security administrator should be looking at. So these are all, the idea here is to kind of give you all these options and tools in your toolbox to understand which one makes sense. And then last one is Amazon Macie, which helps you classify data. So it can look at a S3 bucket, identify if the data has PII level information, and then have a dashboard and notify based on how the data is being accessed. Okay, moving on, encryption in motion or encrypt data in transit. So this is an important feature as well. So as a security administrator, the fact that there are all these different data flow, the network flows of your data, all these different data access patterns, you have to kind of understand what network flow is my request going through. So an example, if you look at an example like S3 and EMR, so the requests going back between S3 and EMR are secure by default. But if a request comes from a client connecting directly to Redshift, it is not secure by default. So it requires a special setting that needs to be enabled called required SSL. It's called a TLS parameter. So it is again, as a security administrator, it's important to understand how the data access patterns are happening, what are the network flows of your data, and make sure each of these flows have the right security in place for encryption in transit. Let's walk through a little bit about authorization. So we're going to talk about this. So when you enable federation, so think about this as a standard Active Directory. You have 80 groups like developer, analyst, and data engineer. When you enable federation with AWS, that gets mapped out to what we call as IAM roles. And IAM roles could look like something like a developer role, an analyst role, or a data engineer role. Once that gets mapped out, those roles needs to be pushed down to individual services in order to kind of do the authorization. So example here is that IAM role called developer role needs to be mapped to a DB group. So if you think about from a standard relational database, things like grants that actually control who has access to what, when you enable federation at the Redshift level, that role can be mapped to a DB group, and then you can control access at that level. At the EMR level, a couple of options, a couple of things here you have to do based on storage-based security or service-based. So service authorization and storage authorization. So EMR security configuration can be used in order to do that. So think about this as access directly to S3 from an EMR cluster. By default, that access happens through a role that the EC2 instance has. But if you want to change that and make sure that it actually is a role of the user that is mapped to, you would actually enable that through security configuration. I'm going to show you an example of that. And then the next, Apache Ranger is one of the other services that you can use that can do the service level authorization. So you can think about a Hive and HBase and some of the other services that can be authorized to that. And finally, data catalog, right? This is the Glue catalog. How many of you have actually tried out resource-based policies on Glue catalog? Okay, just a few of you. So again, an important feature. This is something that was released recently. And what it does is, if you think about the contrast between identity-based policies and resource-based policies, an identity-based policy is something that gets assigned to an IAM user or a role or a group. Resource-based policy goes the opposite. So you actually assign it at a resource level. So some of the services that support currently are things like SQS, SNS, and S3. Glue catalog also supports that. So what you could do is you could go to the Glue catalog, pick up a table, and then say this table has read access for this specific role. So this kind of simplifies the whole authorization model, especially when it comes to catalog. Okay, quickly mapping this. So now, if you from a traditional way of how you actually do ACLs on a database level. So this what you would use is called database grants. A standard grant would look something like that. So on the left, we have a table called user table. We have an AD group called developer. And we use something like a grant group developer, select access to this specific table. Pretty straightforward, right? Now that needs, in case of Glue catalog, because now we have a separation of storage, compute, and catalog. This kind of control can now be inserted directly to the catalog level. And the way you would do that is something like this. So you have an action called glue get table or get partition. The principle here, if you note, is basically the same role that the AD group is mapped to as soon as we do the federation. And then the resource happens to be the table that you want to lock down this control to. So as a security administrator, it's important to understand how this mapping works, because it changes changes this whole idea of doing ACLs at a database level that you're used to on-prem with traditional relational databases, to how you would do that with all this separate compute, storage, and metadata catalog. Okay, moving on to the storage. So S3 is not a POSIX compliance file system, so it doesn't follow the same semantics. So if you have to do like a standard ACL, like read, write, execute, how would you do that? So this gets mapped again to things like bucket policies. So what you see on the left is a standard S3 bucket path. We have an AD group called developer. We want to give him list and get object access. So we have effect, allow, action, list, bucket, and get object, and the principle being the same IAM role that the AD group is mapped to, and the resource being the path of the S3 bucket. Okay, so that's all good. So we got a good sense of the foundational stuff that a security admin has to understand. Now let's go through what we call a scenario-based settings to understand what are the data flows and try to see how we have to secure this. Let's take a quick example of a retail company that has sales, product, and customer. Standard setting, there are sales broken by SKU and customer ID. The SKU is mapped to a product table. The product has SKUs and product category, and as well as a manufacturer, and a customer which has some PI level information like age, gender, and location. So some basic insights that you want to gather from this. Start with that, right? So as a business user, let's say a user who's external to the customer or external to the company, and as a manufacturer, I would want to know what are my sales by a product category. What are my sales by a location? Give me a forecast of what the sales would look like. Now, what's important to understand here is, as a business user, I should not be allowed to see data that is outside of my manufacturer, right? Again, this should be seamless so that when he or she accesses a report, the data is already filtered and presented to him. Second one is analyst. An employee of the company belongs to a specific product line or business unit. They are doing similar kind of analysis. They're kind of doing the sales by the product category. But in this case, there is no filtering required at a manufacturer level, right? So this is saying, give me all the sales by a specific product category. Example could be things like electronics. And the last one is data scientists who are running forecast models and figuring out what the sales would look like based on a specific age group, location, or year. So standard set of questions you might ask from this table structure. So if we have to onboard this, so thinking about kind of going back to that workflow we just discussed, so analysts or a business user is asking this question, get me the sales by a product category. Now this doesn't currently exist in the data catalog, so it's a new data source. We don't have this information. How do I go about doing this? Set up a data pipeline. The data pipeline would involve services like EMR and S3. Once the data is scheduled and you have the data kind of flowing into the storage in S3, the curator, a data curator comes in and basically starts saying, OK, now I'm going to register to a catalog and make sure that it's available for other users to start searching for this information and then start subscribing for it. So it's very important. So if you look on the top, it's the store, discover, subscribe, deliver, and analyze. So this idea that you're storing it, you're making it discoverable, you're giving this option of people to kind of search for it and subscribe. And as soon as you subscribe, the data gets delivered to them or to them the format that they require that in. Finally, the security administrator goes back and kind of sets up the right set of policies. Again, using standard IAM controls to actually control who has access to that data catalog. And then the analyst gets access to it and starts building reports using services like Athena and QuickSight. So if we break down this to the tasks that might be involved, starting with the curator, this initially sets up a staging environment. So think about a staging environment, a staging catalog environment, which is mapped to a staging location as well in S3. And then enable that and give that access to the data engineer to start pushing data into it. And then the security administrator who's involved in kind of enabling the access for it. One thing that you point the second bullet there about the setup at the role level security. So this is where you want to filter the data at the manufacturer level for the business user. So this is what it would look like. So think about it as an access pattern. So what you see on the left is a curator, sets up a staging environment within the Glue catalog, a staging environment within the S3 bucket, and then using an IAM policy. So this is, again, the resource-based policy we just talked about. Both S3 and Glue catalog support the resource-based policy. And using that, you could use a cross-account trust. So again, very important to understand here. What we are seeing on the left side is a separate account from the account that the data engineer is accessing from. And the way you would do that is to enable a cross-account trust between the two, and then use the resource-based policies at a Glue catalog level in S3 to enable that access. So once that is set up, Curator has full access to actually do that as a staging environment. Now that the data engineer has access to it, so this is what it would look like, kind of translating this. So from the catalog policy would look something like that. You would enable database, table, and partition access. Storage grants would look like put, get, and delete objects. And then finally, the EMR configuration. So this is where, if you think about the data engineer trying to actually do the data processing, pulling it from a source system and pushing it to S3, they would use what is called the Glue catalog ID, which is an account ID of where the catalog is present. So this is where the cross-account access comes in. So you have your EMR cluster running in the data engineer account, and then we have the data catalog, which is running on a separate account, and you can access it across the accounts. Okay, a quick view of what kind of controls you can do. Fine-grained access controls. What you see on the left side is basically the giving full access to everything under the blog_dev table or blog_dev database. So it's all tables that come underneath that have full access to it. So things like database start, table start, partition start. What you see on the right side is actually filtering it down. So this is where you're saying, I want to give access to only a set of tables. So prod_star, so using a regular expression here, and then you're saying that this IAM role, when applied to a specific role, would give all access to prod_star or prod_star tables, and then not to anything else. So this is where you can do fine-grained access controls using IAM policies and Glue Catalog. Okay, so now, what does the data pipeline look like? Now going back to the data engineer, so he has now access to the staging environment. Now he should be able to, he or she should be able to start processing and pushing data into it. A few services they might use, things like Amazon Kinesis and database migration service, which can pull data from source relational database systems. Actually, a recent feature that we just added is database migration service can have Kinesis as a target. So you can actually make data coming out from a relational database pushed directly to Kinesis, and then have that as a part of your workflow. A few other things that Tony just kind of touched upon is data sync, the AWS data sync that was launched, or we talked about yesterday, which gives you the ability to use, install agents on-prem and have that send information directly to S3. SFTP as a service as well, which is backed by S3, again, a useful service, which lets you to use a standard SFTP FTP protocol to sync data to S3. Another one here is Scoop that I want to add as well. Scoop is, Apache Scoop is actually a service, a tool that you could use to pull data from relational systems and push it to a data lake like Amazon S3 running on with EMR. Okay, now let's move to authorization. So we got the basic flow kind of set up. Within EMR, there is a few authorization, authentication and authorization things you have to think about. So starting from authentication, cluster level authentication through Kerberos. Various services like Hive and U and Presto and Zeppelin can be authenticated through LDAP. So this is where you do LDAP authentication. And then finally, perimeter security using Apache Knox. Apache Knox is a service that lets you simplify authentication for various UIs. So think about Resource Manager. Think about your Spark UI pages that has to be secured, and you want to actually federate that to make sure that the AD logins can actually work when users are accessing that URL. Also SSL termination at the perimeter, things you could do with enabling Apache Knox. So moving on to authorization, touched upon a little bit on this. This is the storage and service level authorization. So using the security configuration with EMR, what you could do is you can take a developer, map it to a developer role, and put it into the EMR security configuration. Now what it does is when any request happens or goes through EMR FS to S3, the role assumption happens automatically to make sure that the user is, all the access to S3 is done using that specific role. So again, a very important feature if you think about authorization or a storage level authorization. Next one is service authorization. So we talked about a little bit about this as well. Apache Ranger helps you do that. It can do things like authorization of Hive tables, HDFS locations, or HBase, a few more to come. Also, audits provide support for audits. So all the data that's being accessed can now be audited and centrally stored. And column and row filtering, column masking and row filtering is supported for services like Hive as well. Okay. Here's a quick kind of summary slide of everything related to EMR security. I've kind of covered most of it. Just to summarize, Kerberos and LDAP for authentication, EMRFS and Ranger for authorization, and then things like custom AMI, a feature that EMR supports that lets you kind of preload with additional software and also encrypt your root volume. So again, kind of a summary slide of all the things from the 6 things that we talk about: authentication, authorization, audit, encryption at rest, in motion, and compliance. Okay. Now the data is ready. What next? So this is where the Curator comes in. They are actually doing and registering to the catalog, running the sanity checks. So this is where the data is already in the staging catalog. Now you would commission that data set for production. This is where you want to filter around the data for a specific category, right? So this is where you would create a view. So let's look at an example of what the view would look like. So you go to Athena. This is where the curator goes in and sets up a view. The view would look something like this, like create view, sales electronics. And then it has this where clause that locks it down by electronics. Now, why is this important? This helps you put it down, like this gets mapped to a table, a standard table in Glue, and standard Glue level IAM policies apply to this view as well. So now, as a security administrator, you can actually lock down and give the same level of IAM policy to that view, and the data analyst can now access through Athena to this view, which is again sitting in a separate data catalog account. Lastly, quick side, we mentioned about reports. So this is where the business user wants to have access to reports, but that has to be filtered again at the specific manufacturer level. So this is where the last use case we talked about, they want to see a report about the total sales, but lock it down or filter it down to a specific manufacturer. QuickSight is a managed BI service that helps you build visualization. It has a feature called row-level security. So if I want to complete the diagram, this is where the business user comes in. He federates through his IDP and gets a SAML token, connects to QuickSight. QuickSight has row-level security enabled, where all the data gets filtered by the manufacturer, calls Athena. The Athena kind of talks back to the centralized data catalog, and which is actually a view that was created to lock down to a specific product category. A quick summary slide again for security controls on Athena, support for federation. IAM role is used and passed down all the way to the storage layer. And then finally, combining things like Glue catalog policies and views can give you a fine level access control. This is the last one on QuickSight security controls. This one just talks about the same things. We talk about federation. QuickSight give you the ability to do things like QuickSight only users, and also interface endpoints. So if you think about QuickSight needing access to VPC level resources like Redshift and Presto on EMR, you can enable that with interface endpoints. With that, we've kind of covered the new data onboarding. I'm going to hand it off to Tony again to walk us through existing data access.
Thanks, Varun.
Sure.
So let's go ahead and go through something that actually might look kind of familiar, right? The process through which you kind of want some data, you go talk to the catalog, you find it, you ask for permissions, someone gives you permissions, some grants are set up for you. That part's different, right? The setting up of grants. So this one, I kind of want to focus on Redshift, right? Which is different, if you recall, from just simple IAM policies. And we touched upon this a little bit, where Redshift is not a service like Athena. And so you need to consider auth and auth-z as well. And we talked about federation before, and we want to hit it again, because it's actually really, really powerful. You'll note that the analyst in this flow doesn't actually need a username or password local to Redshift. They're able to auth through their IDP, right, using their same credentials they use for Corp. And let's just quickly go through it, right? The analyst asks for a SAML token from their IDP. They throw that token over to IAM. IAM gives them an STS token. They use that STS token to then talk to Redshift to get temporary credentials to log in. And it's really powerful how you can map access in this way to groups within AD, because that's really where you want to be able to turn on and turn off access on a group level basis to your users, to data. Let's go ahead and take a look at how it actually flows up as well, right, when it's going through Spectrum, right? That was just Redshift, but let's talk about the actual Spectrum access. So if no one's familiar with Spectrum, I'll go through it quickly. Spectrum is basically a hybrid approach to allowing Redshift to process data both locally as well as data on S3. And because we are processing data on S3, there are certain considerations, right? We need to look at IAM policies again. We need to think about Glue, because Spectrum uses the Glue catalog as a basis for table registration. So you have to think of all these different components, right? So make sure you map them out when you're doing these assessments. And it's really important to get this right? Federation, being able to do group level management in AD, because if you make it really clunky and make it really difficult for users to be added or removed from groups, no one's going to want to use your data lake. It's going to be too painful to use, and people are going to start doing shadow IT, and it's going to be siloed data sets all over again. So make sure that you do it right. Make sure that you make it secure, of course, but at the same time accessible for your users. And this is what you can do to set it up. Right? Varun kind of touched upon this before, but in general, all you have to do is set up a group in Redshift, and you map it to a policy within IAM, and then you configure SAML assertions for your IDP to map to it. Last but not least, I do want to talk about audit logging in Redshift as well, right? That's one important thing that has come up a lot these days, where customers really want to be able to audit who touched their data. I want to figure out exactly why a select star was run on my data warehouse, because there's really no call for that, right? That typically points at some sort of data exfiltration. And quickly, here's the same sort of best practices list, right, of the key core things you should be doing to secure Redshift presence. So federation, restricting access by IAM policy, using resource tags, using logging with CloudTrail and using your S3 access logs, making sure that you have SSL set up with your communications for cluster communication. And last but not least, here's the last workflow. It's one around data science, where a predictive model needs to be built by a data scientist. And you'll notice that the flow is, again, very similar to the last workflow, right? You're touching data catalog, you're talking to S3, and remember, this pattern is something that's pretty much universal, right, for a data lake implementation. And so securing that catalog, securing that object store is paramount. And then you pull the data after you've been authorized into a notebook, you develop and train the models, and then you deploy and test that model. And one really cool thing with SageMaker is that you can actually have it integrate with Hadoop clusters like EMR. And so typically in a machine learning workflow, you have a prepare phase, followed by a training phase, and then a host phase, right? And it's not enough, again, just to secure the interface through which the data scientist is working, right? The data scientist in this workflow is actually talking to EMR. And so you need to make sure that, first of all, the data scientist doesn't decide to SSH into the EMR cluster, which might have elevated writes and do some nasty things, right? So you need to figure out exactly what access the data scientist has for SageMaker as well as an EMR, and making sure that everything is pretty much kosher there. One interesting thing is that you're not actually today bound just to using SageMaker for managed notebooks. One interesting thing that just came out on EMR is managed notebooks. I think it was maybe last week, where they actually have managed Jupyter notebooks on EMR clusters free of charge. So if you're interested, that's one way that you can kind of keep your attack surface smaller while still giving your users the ability to use notebooks, Jupyter notebooks. And here's another quick slide on SageMaker security best practices. It's fairly light, partially because it's a managed service, but also because it's pretty much the same story over and over, right? You want to encrypt, you want to restrict access via IAM, you want to audit, things like that. So to kind of cap it all off, I do want to talk about how Amazon.com actually uses a data lake. And the consumer business continues to grow, right? And the volume of data grows correspondingly. And last year, I think, during re:Invent actually, Amazon.com actually came up on stage and talked about how they built their data lake on AWS. And quick view here, the challenge for them was really to load 500K transactions a day and serve maybe more than 300K queries and extracts each day from their various business units, right? Amazon.com, Amazon Prime, Music, Alexa, Twitch, all those different sort of business units. And this flow that you see here looks very, very similar to the workflows that we showed you, right? Because it really is something that is very effective when it's implemented correctly. They have DynamoDB capturing all the transactions. Everything is fed into a central data lake on S3. Glue is used to catalog the data, and they have two different kinds of workflows, right? They have Redshift for their SQL-based queries, and they have EMR for their more in-depth analytics, machine learning, big data processing, that kind of thing. And the core goal that they wanted out of their data lake was to be able to ease experimentation, to speed up the rate at which they get insights from data. And they've been having great success with the solution. So if you are interested in this, right, in the interest of time, I'm not going to go too much deeper into it, but there was a session last year at reInvent. It's on SlideShare, it's on YouTube. Go ahead and take a look at it, because they go pretty much in depth on how they implemented it. So, in summary, right, things that we want you to take away from this entire conversation. First, figure out your access, right? You want to limit the amount of places that you need to keep track of users and change their access rights. You want to be able to know clearly what the roles and responsibilities are for every single role that you have in your organization. Set up a matrix around this. You want to leverage that centralized data catalog, right? You want to be able to search on metadata and control based on that metadata as well. You want to use both the preemptive and detective controls that Varun was talking about. You want to perform regular audits of your security posture on your data lake. You want to secure those three core layers: storage, catalog, and processing. And you really want to incentivize your teams to actually use the catalog, right? You don't want them to go back to shadow IT. You don't want them to go back to data silos. So whether it be a mandate from up high, from the C-level, or maybe some incentives such as making it easier for their own users to share data, right? You may have some different data science teams that are really starving for data, so they intuitively want to get more data, so they offer up their data in exchange for other data. You kind of want to incentivize some sort of flow with which teams are actually putting their data sets into the catalog. And this goes back to the point I made earlier, where you want to be able to streamline that process between producers and consumers, right? And that includes access to data sets that are produced and consumed. If it's way too painful for me to get access to a data set via the data lake, I'm not going to use it, right? Unless I really have to. So you want to streamline that process, because in the absence of roadblocks, people behave in a secure environment, right? It's when things are painful that they start doing workarounds. They start leveraging EMR clusters that are overly permissive to access data sets in S3. And that's where you run into trouble. So thank you. And please, please, please complete the session survey in the mobile app. It really helps us get feedback to improve the sessions in the future. Thanks.